In this video, we will talk about the limit laws. We're learning the limit laws in order to figure out how to find the limits algebraically, which is the correct way to find the limits. There is a video that I posted into D2L that explains where the limit laws came from and how can we come up with those limit properties or limit laws. In this case, this video is just a boiled down version of that, just presents you with the limit laws and the limit properties, and it asks you to apply these limits in order to find these properties in order to find the limits algebraically. I advise you to review the videos on how to factor quadratic expressions and how to factor algebraic expression in general before you watch this video, or you can do that after you watch this video. So let's get started with the limit laws or limit properties. Our goal is to recognize the basic limit laws and use the limit laws to evaluate the limit of a function. We want to evaluate the limit of a function by factoring, and we want to use the limit laws to evaluate the limit of a polynomial or rational functions. We will evaluate the limit of a function by factoring or by using conjugates. We will evaluate the limit of a function by using the Squeeze Theorem or the sandwich theorem. If we have a function f of x and g of x, and both are defined for all of the x's that are not equal to a over some open interval containing that a, assume that L and M are real numbers such that the limit of f of x when x approaches a is equal to L, and the limit of g of x when x approaches a is m. Let c be a constant. Then each of the following statements hold. The first statement says, if you have the limit of x as x approaches a, then the limit is going to be equal to a. Basically, you're going to plug a into x and you got your limit. If we have the limit of a constant when x approaches a, then we will have the limit equal to that constant. It's not going to change. And again, you can see step by step how we came up with these laws and these properties using information that we have before. And the video is posted already on D2L. So make sure that you go ahead and see that. Number 3, if you have a limit of two functions added, f of x plus g of x, when x approaches a, then we can take the limit of each function individually. This applies for all polynomials. If you have a polynomial, then the limit of the polynomial is the limit of each term in the polynomial, and then you add them together. Same holds for subtraction. If you have two functions, then the limit of f of x minus g of x when x approaches a is the limit of f of x when x approaches a minus the limit of g of x when x approaches a. And we assume that the limit of f of x exists and is equal to L, and the limit of g of x exists and it's equal to m. So the final answer will be L minus m. If you have a limit of a constant times a function f of x when x approaches a, then we take the constant out and find the limit of that function when x approaches a, which is equal to the constant times the limit. If you have a product of functions, then the limit of the product of functions is the product of the limits for these functions. If you have a quotient function, then the limit of this quotient function is equal to the limit of the numerator function over the limit of the denominator function. And there is a typo here. This is supposed to be g of x. G of x, which is equal to L over m. In this case, we say that m shouldn't be equal to 0 because that will be undefined. 8th, if you have a function raised to the n power and n is a positive integer, when x approaches a, then the limit of f of x to the n power is the limit of the function f of x as x approaches a raised to the n power, and that is equal to L to the n power. Again, n should be a positive integer. If you have a limit of a radical, if you have a radical function then the limit of the radical function as x approaches a is equal to the nth root of the limit of the function as x approaches a, and that is equal to the nth root of L if n is odd and for all L greater than or equal to 0 if n is even. Because we know that the cube root of a negative number exists, but the fourth root of a negative number is actually a complex number. Let's find some limits. We have the limit of 2x squared minus 3x plus 1 over x cubed plus 4 when x approaches 2. Let's check if the limit as x approaches 2 exists if we use the limit laws that we know. So we have a quotient here. That means the limit of this quotient is the limit of the numerator function over the limit of the denominator function. So this is basically equal to the limit of 2x squared minus 3x plus 1 as x approaches 2 over the limit of x cubed plus 4 as x approaches 2. So in this case, we have a polynomial. So the limit of addition and subtraction of functions is basically the limit of each of these terms individually. So this will be the limit of 2x squared as x approaches 2 minus 3. Minus limit of 3x as x approaches 2 plus limit 1 as x approaches 2 over the limit of x cubed as x approaches 2 plus the limit of 4 as x approaches 2. If we do that further, we get, notice how the first limit here, the first limit has a constant, so we're going to take that constant out according to the properties. So this will be 2 limit x squared as x approaches 2 minus, again, we're going to take the 3 out because it's a constant, 3 limit x as x approaches 2 plus limit of the constant is the constant itself over limit x cubed as x approaches 2 plus limit 4. In this case, this is basically limit of the constant is a constant. So in this case, we have a function raised to the n power, and it's positive integer. So we can say this is equal to the limit 2 times the limit of x as x approaches 2 raised to the second power. We can rewrite it like that using the properties. We know limit x as x approaches 2 is equal to 2, so we have minus 3 times 2 plus 1 over, similar here, we're going to say limit x cubed is basically limit x all to the third power as x approaches 2 plus 4. Then eventually we're going to compute. We know that limit x as x approaches 2 is 2, and similar here, so we're going to say 2 times 2 squared minus 3 times 2 plus 1 over 2 raised to the third power plus 4, which is eventually going to give you, and remember PEMDAS when you do expressions like that. So we will have 4 times 2 is 8 minus 6 is 2 plus 1 is 3 over 2 cubed is 8 plus 4 is 12. Reduce that, you'll get 1 over 4. So the final answer for this limit is equal to 1/4. Let's look at another example. Now the first thing I usually do, I look here and I see when I substitute x is equal to 3 in the denominator, will that create a 0 here? If that is the case, I don't proceed with the properties right away of the quotient where I put the limit on top, and when I find the limit of the numerator and the limit of the denominator, I simplify this expression to eliminate the denominator, which is the troublemaker. In this case, I don't see that, so I'm going to proceed just like the previous steps. So this basically is equal to the limit of 2x squared minus 3x plus 1 as x approaches 3 over the limit of 5x plus 4 as x approaches 3. So if I apply the limit laws, I will have limit of the 2 comes out, x squared, as x approaches 3, minus 3 out, limit of x as x approaches 3, plus 1 over 5, limit x as x approaches 3, plus 4. Since I know the limit of 4 is going to be 4, the limit of 1 is going to be 1. So here I apply right away. Now I'm not going to turn this into the property. I know the property, so I'm going to apply this right away. So I will have 2, and then limit x when x approaches 3 is equal to 3, and then we square that. The answer is 9. Minus 3 times the limit of x as x approaches 3 is 3, so 3 times 3 is 9, plus 1 over 5 times the limit of x as x approaches 3 is 3, plus 4, which is equal to 18 minus 9 is 9, plus 1 is 10, over 15 plus 4 is 19, which is the final answer. So the limit of this function is 10 over 19. Let's find this limit. So according to the properties that we studied, then we're going to apply the properties of the limits here. Again, this is equal to 2 times the limit of x as x approaches 6, minus 1, the limit of 1 is 1, over, when we have a radical, then the limit of the radical is the radical of the limit. So the radical of the limit of x as x approaches 6, plus the limit of 4 is 4. Now we compute, we have 2, limit of x as x approaches 6 is 6, minus 1, over the radical, or the square root of 6 plus 4, which is in this case 12 minus 1 is 11 over the square root of 10, and that is the final answer for this limit. Let's find this limit. Well, this limit is basically the limit of a polynomial. To find the limit of a polynomial, you're going to find the limit of each of these terms, and we know how to do that, so we're going to apply the property right away. So this is equal to 3 times the limit of x cubed when x approaches negative 2, minus 2 limit x when x approaches negative 2, plus the limit of 7 is 7. This is equal to 3 times, again, I'm going to do that quickly, the limit of x when x approaches negative 2 is negative 2 to the third power. So I'm going to say negative 2 to the third power, minus 2 times negative 2, the limit of x as x approaches negative 2 is negative 2, plus 7. This will be 3 times negative 8, which is negative 24, plus negative times negative is positive, 2 times 2 is 4, plus 7. Again, apply PEMDAS. So you're going to say 24, negative 24 plus 4 is negative 20, plus 7 is negative 13. If you have a limit of 4x cubed plus 2x minus 4 when x approaches negative 3, you're going to apply the same rules. So you're going to say this is equal to the limit, 4 times the limit of x cubed as x approaches negative 3, plus 2 times the limit of x as x approaches negative 3, minus 4, the limit of negative 4 is negative 4. Now we apply the limit laws that we know. So 4 times the limit of x as x approaches negative 3 is negative 3, all to the third power, plus 2 times the limit of x as x approaches negative 3 is negative 3, minus 4, which is equal to negative 27 times 4 minus 6 minus 4 equal to negative 118. Let's do the last one. So we have the limit of x squared minus 4 over x minus 2 when x approaches 2. If we do that using the limit laws, let's see what happens. So this is limit x squared when x approaches 2 minus 4. We know that the limit of negative 4 is negative 4 over limit x when x approaches 2 minus 2. This will be the limit of x squared when x approaches 2 is 4. Please verify. minus 4 over 2 minus 2. So you'll have 0 over 0. Oops, but that is a problem. So how can we solve this type of problems? I will show you exactly the steps that you're going to follow in order to solve this type of problem in the next video. For now, I hope this video helped you understand how to start solving limits algebraically, and I will see you in the next video to teach you how to solve this kind of problem.